Today in Capechi's Corner, we're going to look at proportional lengths. In our first theorem, we're going to look at the triangle proportionality theorem. And what it says is if a line is parallel to one side of a triangle, intersects the other two sides, then it divides those sides proportionally. So if we look at our diagram, we do have a set of parallel lines here. Line PQ is parallel to RS, which is part of the triangle. So we can say, because of that, that RP, so this piece right here, RP is to PT as SQ is to QT because it divides those sides proportionally. Because of that theorem, we have a lot of different proportions that we can use with these parallel lines. So I can say that AJ is to CK, that's one proportion. I can say BJ is to DK. I can also say AC, the top of that triangle, is to BD. I can say AB is to CD. I can say BD is to JK, so the smaller portion of the triangle is on the bottom as opposed to the whole side. And I can also say that AC is to JK. So because of this theorem, there's a lot of different proportions we can set up with pieces or parts of the triangle. Now let's look at an example. So in number 1, it says if CB is 12, so if this whole piece is 12, and I know that EB is equal to 4. Now because of that, I can see that then CE is going to equal 8, so I'm just going to mark that. And I know that CD is equal to 6, and I'm trying to find DA. Now because those lines are parallel, I know I can set up a proportion. So I can say 4 is to 8 as x is to 6. So I can say 8x is equal to 24. Therefore, x is equal to 3, which is the measurement of AD. In number 2, it says that CD is 6, so I'm going to mark that, and DA is 3, and we know DE is also 3. We're trying to find AB. Now this one's a little different. This is where you have to pay attention to. We have a smaller triangle, which is right here, as opposed, here's our small triangle, as opposed to our large triangle. So we kind of have to keep that in mind. So my larger triangle, this side right here, AC, has a value of 9. So when I'm setting up my proportion, I have to be aware of that. So I can say that in my small triangle, 6 is to 3, my DC is to 3, as my long side there, 9 is to x, because that's both on my larger triangle. I cross multiply, I have a 6x is equal to 27, and x is equal to 4.5, which is the value for AB. Now I have a corollary, which is something that kind of feeds off the theorem. So this is the corollary to the triangle proportionality theorem that we just looked at. It says if 3 parallel lines, so here's my 3 parallel lines, intersect 2 transversals, here's my transversals, then they divide the transversals proportionally. So again, I'm not saying that these segments are congruent, I'm saying it divides it proportionally. So what I can say is, here's my proportional statement, RS is to ST as LN is to NE. Let's look at an example. I know that I have 3 parallel lines and 2 transversals, so I know the transversals are marking off those segments proportionally. So I can say that 4 is to 8 is the same as 5 is to x. So I can say 4x is equal to 40, so x is equal to 10. Now if I know x is equal to 10, I know y is 5 plus 10, so I know that y is going to be equal to 15. Our last theorem for today is called the triangle angle bisector theorem. And what it says is if a ray bisects an angle of a triangle, then it divides the opposite side into segments proportional to the other two sides. So here's my ray right here. So what it's saying is it divides these opposite sides, C and D. So CD is to A over B. C is my numerator. The side next to it's going to be also my numerator, and the same thing with D. D on this side is my denominator, so I need to make sure I match that up with B. Let's look at an example. This one says to find x. So here's my ray that divides my angles evenly. So I can say that since this whole piece is x right here, I can say this piece right here is going to be x minus 10. So when I set up my proportion, I can say 10 over x minus 10 is equal to, now 10 on my numerator is next to this 12, so that's also going to be my numerator, 12 over 24. So when I cross multiply, I get 24 times 10, which is 240, is equal to 12 times the quantity of x minus 10. So it gives me 240 is equal to 12x minus 120. Add the 120 to both sides, and I have 360 is equal to 12x. So x is going to equal 30. So that's my value for x. X is equal to 30. Now I could have done this another way. I'm going to just change color so you can see. So let's just say I decided to make this side y. So I could have also set up my proportion 10 is to y as 12 is to 24. And I would have same thing cross multiply. 240 equal to 12y, divides both sides by 12, and I know y is equal to 20. So if y is equal to 20 and the other side is 10, I know that x is going to be 10 plus 20, which also gives me 30. So again, it doesn't matter which way you do it as long as you understand how the proportions are set up. We're going to look at a few final examples for today. We're going to be asked to find the value of x. So down this left-hand side, if I know the whole piece there is 33 and my smaller side there is 12, I know that my other value there is going to be 21. So I can set up a proportion. I can say 12 is to 21 as 20 is to x. Cross multiply, I have 12x is equal to 420. And then I have x is equal to 35. In my next example, I see that I have a triangle and I see that I have a ray that bisects the angles. I know if the whole piece here is 40 and the other side is 25, this is going to make this piece right here 15. So I can set up my proportion. So I have 15 is to 25 as 18 is to x. Now when I cross multiply, I have 15x is equal to 450. Divide both sides by 15, and I know x has a value of 30. Now, in looking at our last problem for today, I notice I have 3 parallel lines that are cut by transversals, so I know they're going to divide things proportionally. So I know I can set up my proportion that 18 is to 9, as 24 minus x is to x. So again, I cross multiply, so I have 18x is equal to 9 times the quantity of 24 minus x. Now I'm going to distribute, so I have 18x is equal to 216 minus 9x. Now I need to get my x's on the same side, so I'm going to add my 9x to either side. And I have 27x is equal to 216. Divide both sides by 27. I know x has a value of 8.